Okay, so we're going to look at all of our special right triangles and where they come from and what we do with them. Well, not all the things we do with them, but we're going to just kind of build all of our special right triangles after we figure out where they come from. So starting with this equilateral triangle. Okay, so equilateral just means that all of my sides are exactly the same. Good old geometry concepts here. And all of the angles are also the same, which makes them all 60 since the sum of the angles of a triangle add up to 180. So obviously this isn't a right triangle, but if we take this thing and we draw a line directly through it, what we've created is two right triangles that are exactly the same. So now if I pull this out, first of all, if this is 60 and I cut it directly in half, this would make this a 30. So this is one of our, that is a horrible 60, 30, but that's fine. So this would be our 60, this would be our 30. Again, not drawn to scale, that's a horrible job. But thinking about the sides here, if this is x, then this is now x over 2 because we've now cut that side in half as well, so that becomes x over 2. And then this over here is whatever that is, I'm not sure, but we can figure it out in terms of x. So if I use Pythagorean theorem, I would have b squared plus x over 2 squared is equal to x squared. Okay, so a squared, b squared, c squared, and we go from there. So b squared plus x squared over 4, which is going to be equal to our x squared, which means that b squared is going to be 4x squared over 4, just getting a common denominator there, minus x squared over 4, which would be 3x squared over 4. Now I'll take the square root of that, and I've got b is equal to the square root of 3 over 2x. Okay, square root of 3 is just the square root of 3, square root of x squared is x, and the square root of 4 is 2. So that would be my b value there. So this side over here is the same as the square root of 3 over 2 times x. Now, if we go and we place this thing inside of our unit circle, when we do that, we've already talked about our unit circle a little bit. Let me see if I can draw a better triangle here. So 60 degrees is about here-ish. Okay, so if I think about being inside my unit circle, well, that means that this piece right here is going to be 1. Okay, so if this guy right here is 1, then that would be my x value. So that would mean that x is equal to 1, which means this side over here is 1/2, and this side over here is the square root of 3 over 2. Now, mathematicians, much like students, tend to not like to have fractions either. So if I pull this triangle out and keep it proportionate, so we have similar triangles here, where our angles are going to stay exactly the same, but we're going to multiply all these values by 2, and we would get 2 square root of 3, that's a 3, and then 1. So 1, 2 square root of 3. This is one of our special right triangles that we use a whole lot in math. So this is one of them that we're just going to kind of memorize, because there's two really that we really need to memorize, and once we have those memorized, building the whole entire unit circle becomes very easy, and we can do it very, very quickly if we have this guy right here memorized, along with our next one, which instead of a square actually comes from, instead of an equilateral triangle actually comes from a square. So if we take a square, which obviously has 4 90s to it, and all these sides are exactly the same, and we were to bisect it through one set of them, I create 2 of them that have the exact same dimensions, which would be 45, 45, 90. So this is our 30, 60, 90. This is our 45, 45, 90. So pulling that off to the side, looking at just this piece right here, 45, 45, 90, this is x and this is x. We didn't really do anything with either of those sides, so they're both still x. And this over here would be our, let's just call it c for the moment. So x squared plus x squared equals c squared. So 2x squared equals c squared, and when you square root both sides, you would get x times the square root of 2 is equal to c. So that would make this side right here would be x square root of 2. So then same sort of concept. If I were to take and plug this thing into a unit circle, that has unit circle, of course, radius of 1. I guess I should have said that in the first one. I'm just assuming that you knew that. But if we plug it into the unit circle, then again, that radius is 1. That's what makes it a unit circle. And so that would mean that x square root of 2 equals 1, which means that x is equal to 1 over the square root of 2, or if you rationalize, the square root of 2 over 2, just depends on what the answer keys or whatever looks like. But then that would give me that. So if I pull this, if I take a look at this 45, 45, 90 here, and I have 1 and then 1 over the square root of 2 and 1 over the square root of 2, same sort of concept. We don't want to really leave fractions here. So if I just multiply everything by the square root of 2 to get rid of my fractions, then I would end up with this triangle that is a 45, 45, 90, which is going to be 1, 1 square root of 2. Okay, so this would be the other one. This is our 45, 45, 90, which is 1, 1 root 2 that we would memorize, and then this is our 30, 60, 90, which is 1, 2 square root of 3. Okay, so those are the main triangles that we're really working with, and then everything else is kind of built off of those as far as all the special right triangles. Okay, but those are the two main components of it. And then when we start looking at putting these things into our building our whole unit circle. Okay, so we'll talk about that. So part of trig is using our special triangles and things like that because they show up so much. Let's see, this thing focuses back in. There we go. So we want to be able to build this whole unit circle and where these things are. So let's start with our 60 inside of our unit circle. Please excuse the circle. But basically we're starting with our 60-degree angle here. So if I'm looking at a 60, we just figured out that my values here are 1, square root of 3, and 2. Don't confuse the fact that we now have a 2 here, because again, we're just going to use the proportionate triangle without the fractions as opposed to using the one that has the 1 on the diagonal. So just keep that in mind. We're still talking unit circles here, but for the sake of this, I am going to write it the way we're going to do our sine and cosine. So just keep that in mind. I'm going to write it out that way. But here, so if I want to do this particular one, so we're at 60 degrees here, and then we talked earlier about the fact that x is equal to the r cosine of theta. And then for our unit circle, our r value is going to be 1. So that means that x is equal to the cosine of theta. So when we think about an ordered pair that exists here, the x value of it will be the cosine of theta. So let's talk, what is the cosine of 60? Well, we have our triangle here that we can build out, and cosine is adjacent over hypotenuse, so the cosine at 60 is 1/2, adjacent over the hypotenuse. So that would be my x value. And then we also talked about the fact that y is equal to r sine of theta, which for the unit circle is just going to be sine of theta, because it's 1 times the sine of theta. So our sine of 60 is going to be the opposite over the hypotenuse, which is the square root of 3 over 2. So the ordered pair that exists here, the x is 1/2, and the y is the square root of 3 over 2. Okay, so that's where it'd be for a 60-degree triangle. Now, after that, we can go through, and without having to really do any other real work, we can kind of fill out the rest of them. Because once I get over here, so 60 plus 60 gets me to 120. So the degree right here is going to be 120 degrees. Okay, but my reference angle right here is still 60. Because if this is 180 degrees, because it's 360 all the way around a circle, so that means halfway is 180 degrees. If this is 360 all the way around, hopefully we know that a circle is 360 degrees. Half of that is 180. So if this whole thing is 180, from here to here is 120, well, that makes this little piece left over 60. So we call those reference angles. So my reference angle here is 60. So it's still going to be the exact same triangle, the only difference is now that we're in the coordinate plane, when I'm over here in quadrant 2, well, my x value is going to be negative. Because on this side of the y-axis, the x values are indeed negative. The y value is still positive. The hypotenuse will always be positive because it's a squared plus b squared. So this is the only thing that changes. So that means the ordered pair here is going to be negative 1/2 and positive square root of 3 over 2. Okay? Negative 1/2 and positive square root of 3 over 2. That is going to be my cosine and my sine. Okay? And then you can keep going with that. So the next one, 60, 120, 180 would be here. That doesn't really make a triangle, so we'll come back to that. Next step would be 240. Just 180 plus 60 is 240 degrees. And same sort of thing, but now my y value is going to get... from here, same sort of idea, only now we're going to have that negative y value that goes along with it. Hypotenuse, again, always positive. So my cosine is negative, and my sine is also negative because it's in the third quadrant. So down here in the fourth quadrant, adding 60 again would get us to 300 degrees, which is 60 back from here. So we're still in that 60-degree reference angle, which would be the 2 and the negative square root of 3 because I'm below the x-axis, but I am to the right. So now my cosine is going to be positive, and just my sine will be negative. Okay, so no need to memorize all these things. That's a lot of things to just straight memorize when you can just build the entire thing. So let's go through and do our 30s as well. Which is really just the same graphs, but my bow tie is a little bit smaller. I always call these the bow ties. I don't know. That's what they always reminded me of. So my bow tie here, my 30 degrees, is just a little bit smaller there, but it's the same general concept. Now, here, it's still the same triangle. We already did the 60, 30, 90, but we're going the opposite direction. So across from the 30 is the smaller side, which is 1, and the long side here is the square root of 3, because square root of 3 is larger than 1, and that's something that kind of always helped me. The square root of 3 is definitely bigger than 1. So it has to be the long side, and the 1 is the short side. And when we're talking the angles, just by the sheer size of the angle, the small one has to be across from the 30, and the large value across from the 60. And then 2 is always the hypotenuse. So from there, same sort of idea. So the cosine of 30 then is going to be the adjacent over the hypotenuse, and the sine is going to be 30, is going to be the opposite over the hypotenuse. So these things are just going to switch sides. Okay, that's really all there is to it. So now all of my sines and cosines kind of switch. So that's pretty easy to remember too. So here at 30, we're going to end up with our cosine being the square root of 3 over 2, and our sine being 1/2. 30 plus 30 is 60. We already did that. Plus 90 doesn't make a triangle. Plus another 30 gets me to the 120, which we've already done. So then the next one up would be the 150. Okay, so 150 degrees is the first one that doesn't reduce down to something else. So 150, which again we end up with that reference angle there. So same sort of general concept. The x value now is negative. The y value is still positive. Hypotenuse is always positive. So the cosine over here is going to be the negative square root of 3 over 2. And the sine is going to be positive 1/2. Next quadrant. There's always only 1 in each quadrant, by the way. Everything else will reduce down to something else. So here the 30, we are now at 180 plus 30 would make 210. So 210 degrees. This is now negative 1, so my cosine would be negative square root of 3 over 2, and my sine is negative 1/2. Last one would end up over here. Everything else in between would simplify. This would be a negative 1 also, so my cosine is positive and my sine is negative. Okay, because again, the cosine values are always going to be positive to the right of the y-axis, and negative to the left, and then all my sign values will be negative below and positive above. Okay, just like you would think a normal graph, which these are really normal graphs in general, but we're just tossing angles in the middle. Okay, so let's go through the 45. Try to make this one a little bit bigger. Did say a little bit. Okay, so he already did that one too. 1, 1, root 2 is what we're looking at. So if I'm talking the 45, 1, 1, root 2. So then the cosine of 45, sorry, that's 45. So the cosine of 45 is going to be 1 over the square root of 2, which could also be written as the square root of 2 over 2. You kind of have to pay attention to whether they need it rationalized or not. When you're doing this in Canvas, they should tell you exactly what your format will look like. Typically, you'll see it like this in anything that has older text. They're starting to get to where they don't always rationalize the denominator, but the unit circle may have it still written like this. But the cosine of 45 is square root of 2 over 2, and the sine of 45 is 1 over the square root of 2, which is the square root of 2 over 2. Okay? They're both exactly the same, so here we go with these. So we've got the cosine is the square root of 2 over 2, and the sine is square root of 2 over 2. Okay? And then we would have 90, and then plus 45 would be 135. So 135 degrees, our x value, so we would have negative 1, positive 1, square root of 2. So this would just make negative root 2 over 2 and positive root 2 over 2. Then we'd get to 180, and then 180 plus 45 would be 225. X value would be negative. Sine value would be negative. Sorry, that's small. So negative square root of 2 over 2, negative square root of 2 over 2, and then the last 45 there, same idea, negative and positive, and the square root of 2. So my cosine, plus 45 would be at 270. That would be right here. Goodness gracious. I was like, why does that not make any sense? This is 270. I'm so sorry. So this is 270, and then plus 45 would be at 315. That makes a lot more sense. And then 315 to 45 makes 360. Okay, now we're moving. All right, so then same sort of thing. The x value now, though, is going to be positive, so the square root of 2 over 2. And the sine value will be negative, so negative square root of 2 over 2. So that's the 45. So then the only thing left are the 90s, 180s, 270s, and 360s. So when we're looking at this, to get these points right here, even though they don't really make a triangle per se, we're still sitting on a unit circle, and these are just ordered pairs. So if I have this point right here, okay, well, if my radius is 1, then the x value or cosine value here is just 1, and then the sine value there would be 0. Because I've gone up, because this is still an xy value, so x is 1 and y value is 0. So that would mean that the cosine of 0 is 1, and the sine at 0 is 0. Okay, and you could do that for each one. So the ordered pair that exists here x is 0, y would be 1, because again we're talking about a radius of 1. So from here to here should just be 1. Okay, so over here at 90, you have the cosine is 0 and the sine is 1. And then we've got our 180, which would be at negative 1, 0. And then you have your 270, which would be at 0, negative 1. Okay, so that would be it. So this allows me to fill in most of my unit circle. So all of this, you would just throw it all onto one unit circle. They don't ask you to put all of the dimensions inside. I just kind of do that when I'm building this. But you're just going to fill out basically all of the ordered pairs for the points, and then all of the degrees. And then the only thing we got to do to finish out our unit circle in our packet here, because now we can do all of those, and we can do all of the degrees, So the only thing that is missing there is to go through and do our radians measures. But we'll look at radian measures tomorrow. So that's what will come up in the next videos. We'll look at converting degrees into radians, and then we'll also talk some coterminal angles and a little more on reference angles. So that is what you're looking for those. So now you've got most of those special triangles. So just to kind of reiterate, these hopefully are kind of logical. You need to, the easiest way is to memorize just the one circle. Okay, you don't have to memorize everything. I'm sorry, one circle, the one triangle. You don't have to memorize that whole entire thing. All of it is built off of these two triangles right here. My 30, 60, 90 and my 45, 45, 90. So if I know these two things, then you can very quickly do a ton of the trig that is going to show up in your world. So I used to, personally, I would always, when I get started on like my homework or my exams, I would go ahead and draw out my little bow ties just to make my life easier, because that's how I got fast at it, is I would draw out those bow ties until I just knew that the cosine of 30 was going to be the square root of 3 over 2. That kind of came later, but I would just quickly draw out my bow ties, because then I could find any of the trig functions for any of my special triangles, my cosines, my sines, my secants, my cosecants, my tangents, my cotangents. I could quickly find all of those just with those 3 cute little bow ties there. Just made my whole life easier. But just kind of do whatever it is you want to do. If you want to take the time to build out the whole entire unit circle, you can. If you want to, whatever the case may be, you do that. But you definitely need to know those two special triangles so that you can build out the rest of the unit circle. I think the biggest mistake that I see amongst a lot of people in math is trying to just memorize this whole unit circle, which just sounds horrible, to just memorize the whole unit circle when you could really memorize the two and just create everything else from there. Okay? So learn to build it. Don't learn to memorize it, because that's a lot of stuff to memorize. Okay? I hope that helps.